Hi everyone, welcome to our video on finding the extreme values when we have a rational function. Alright, so it is the same process that was in our previous video with our 3 steps from before. Okay, so let's just break it down right here. Alright, so we have our function. What we want to do if we're finding the extreme values is for step 1. Let's go ahead and get our derivative. So this is a quotient, so that means I would do my f prime of x is my low d high minus my high d low all over low low. And that's minus there. Okay, and then I've got, let me go ahead, I can use some colors. Let's get blue. So the blue will be the high portions, just to make it colorful. And then let's do red for the low portions. Okay, so if needed, these functions aren't that bad, so we might not really need it. Okay, but what we're going to do is just plug all those in. Okay, so I've got my f prime of x is, let's get my big fraction ready. Okay, so my low portion is the 4x minus 3. So I'm going to put that in. So 4x minus 3. The derivative of the high, well, that's just 2x. The derivative of high is 2x. And then we have our minus. The high portion is just x squared. And there's that. And then our derivative of the low portion would be 4. All over our low portion, 4x minus cube, or 4x minus 3, I saw that as cube for some reason, 4x minus 3 squared. Okay, so there's our function written out. And then now what we need to do is look to simplify. All right, so usually we either try to factor or we combine like terms. So for this, that got a little out of control. For the numerator, let's go ahead and distribute this 2x. So the 2x, I'm going to distribute in, so that gives us 8x squared minus 6x. And then this negative and the 4 all multiply, we have minus 4x squared. And then down below, I still have 4x minus 3 getting squared. All right, so there's all those. And then now I need to continue simplifying this. So we've got f prime of x. Look at our numerator. It looks like 8x squared minus 4x squared would become 4x squared. And then minus 6x all over 4x minus 3 squared. Okay, so I simplified it. It looks like that now. And then now that we have it simplified, well, actually it factors. Look at the top there. So the top, it looks like 2x is in common. So let's get a 2x out. And we would be left with 2x minus 3 over 4x minus 3 squared. Okay, so let me cloud that. So this is the factored. I like clouding things that aren't our final answer. Okay, so that's our factored derivative. And then now I want my critical numbers, which means I'm going to set every part of my factors equal to 0. Okay, so if it's a fraction or a rational function, you set every factor equal to 0 for the critical numbers. Okay, so what we're going to do is just do 2x equals 0, 2x minus 3 equals 0, and the 4x minus 3 squared equal to 0. So I want to do all of these. So this is for the critical numbers. Okay, and this first one's pretty nice. All I have to do is divide by 2, and I get x is 0. But let me go ahead and put a stop right now on this. Notice 0 is not in this interval from 1 to 3. So that means this is not part of our critical numbers. Okay, so I'm going to just cross it out. Okay, so 0 is less than 1, so that's not one of the actual critical numbers. With this, if I add the 3 over and then divide by 2, I would get x is, let's go ahead and make it a decimal. It would be 1.5. So if I add the 3 over, divide by 2, it would be 1.5. 1.5 is between 1 and 3, so that means this is a critical number. And then our next one, 4x minus 3 squared. Well, I would square root both sides to get rid of the square. And then we could add the 3 and divide by 4 eventually. So I'm just saying the steps in words because I'm running out of room on this. But eventually we would get x is 3/4 or 0.75. Either way, it's not in that interval. So this is gone as well. So that's not a critical number either. Okay, so x equals 1.5 is the only one. Okay, and then now at this point, step 2 is to evaluate these. Okay, so we want to do our n numbers, so f of 1. Let's just set them all up. F of 3, and then f of 1.5. Okay, so I just want to plug all those in. All right, and then with this point, this problem, I'm going to go ahead and just go to the calculator first instead of doing the arithmetic. Okay, so our Desmos, and then let's get a different, let's clear it out, delete all. Okay, so I want to just plug in my function. So it's x squared, and then divided by 4x minus 3. And then let's make it so we can see it. Okay, and even if we wanted to put it in the interval, we could do our brace and put it in. So it would be something like this with 1 less than or equal to x less than or equal to 3. And then another brace. Okay, so that's if you wanted to see it with that actual given interval. It's not really super necessary. We would plug it in anyway. But notice that's all the graph is. It's just that small little red piece now that we plug that interval in. Okay, but the main thing is I want the actual numbers. That's where I'm just going to go to my table. And let's plug those in. So we have 1, 3, and then we also had the 1.5. And then all the rest were not in it. So let me just delete them. All right, so those are gone. So those 3 points now in our picture are the only ones that are important to us. Well, we saw this in the last one. Our biggest y coordinate looks like it's tied. We got a tie. It's 1. Our biggest y coordinate is 1, and then it looks like our smallest y coordinate is 0.75. And if we needed to, we could change that into a fraction. So 0.75 would be the same as 3/4. But I'm going to say let's leave it as a decimal. Okay, so there they all were. So when we plugged in 1, we got 1. When we plugged in 3, we also got 1. That was based on our graph. And then when we plugged in 1.5, we got 0.75. And so now we have our answer. The biggest one of these is 1, and we do have a tie. So now our step 3, our absolute max is 1 at the 2 x values it occurred at. So it occurred at x equals 1 and x equals 3. Our absolute minimum is the 0.75 at the x equaled 1.5. And there we go. Okay, and so there's our calculator helping us out. Again, the graph by itself could answer this. We just have to know how to work it. But I would say it's, again, make sure you are good with calculus because, well, other problems involve calculus, so we need to make sure we're good at it. All right, but that's it. I'm going to stop this video. So it's the same process. It doesn't matter what the function is, but just so you can see different functions, I'm going to separate them. All right, so that's everything. If you have any questions, please let me know. Otherwise, thank you for